The demand for the Cybertruck far outweighs current production, but the true reason for the scarcity is the immediate prioritization for a specialized global mission. This is a sentence that might sound surprising. Most of us see the headlines. We see the long wait lists. We hear about the manufacturing challenges. The simple story is that Tesla cannot build them fast enough to meet the incredible demand. And while that part of the story is absolutely true, it is not the complete picture. There is another layer, a strategic choice that reshapes the entire production line and decides who gets a truck and when. This essay will peel back that layer and tell that story. Reservation numbers climbed into the millions, and the media framed it as classic supply and demand. Inside, a team looks at the limited vehicles rolling off the line and makes specific choices about where they go first. Think of it not as a secret, but as a dual purpose baked into the Cybertruck's very DNA. Let's start with the most visible innovation, the high-strength stainless steel. This isn't the kind of metal used on your typical sedan or pickup truck. Most vehicles use malleable steel or aluminum that are easy to stamp into familiar curves. The Cybertruck's Exoskeleton is an ultra-hard, cold-rolled stainless steel alloy. It resists dents, scratches, and certain types of projectiles. Great for daily drivers who hate door dings, and for teams that need protection. But that same strength makes it a nightmare to manufacture. Traditional techniques do not work. They reportedly score with lasers before folding. The process is slower and more precise. Small errors waste expensive sheets, creating a primary bottleneck in daily output. Exhaustive testing validates crumple behavior and durability from deserts to tundras. That toughness gives peace of mind. From school runs to hazardous zones, each truck is a testament to a slow, deliberate, difficult process. Beyond the tough exterior, the Cybertruck is a deeply complex technological device. It's more a computer on wheels, relying on tightly integrated software and hardware. It manages steering, acceleration, navigation, and onboard power. For specialized missions, integration becomes critical. Advanced sensors, powerful processors, and redundant systems go beyond consumer baselines. Long-range thermal cameras, sophisticated radar, secure communication arrays. The software must be bulletproof. A glitch in a rescue could be catastrophic. Code is written, tested, rewritten, millions of lines to eliminate bugs and harden security. System integration, making everything work in harmony, is a massive undertaking. Mission-specific parts are low volume, fragile in supply, and can halt batches. Even a small software or chip delay can hold hundreds of vehicles. This meticulous integration slows things down, but ensures reliability. The third key reason for the Cybertruck's scarcity is its inherent dual-purpose design. Tesla is not just building one truck, it is building a platform to serve two very different masters. For the consumer, statement piece, workhorse for lumber, family vehicle for road trips, comfortable, user-friendly, stylish. For the tactical user, first responders, remote industrial sites, security forces, rugged, reliable, adaptable. Balancing both in one framework means creating and managing different variants. Mission-ready versions need reinforced chassis, specialized mounts, auxiliary battery packs, and secure communications. Each mod requires separate supply chains, dedicated assembly procedures, specialized QC. A rural fire department ordering upfitted trucks, winches, floodlights, medical racks cannot be filled by standard consumer units. A dedicated team upfits the fleet, time, skilled labor, specific parts, diverting resources from the general waitlist. Every prioritized, specialized order pushes individual consumer timelines longer. It's a simple resource allocation trade-off between volume and capability. Building mission-capable early means fewer units for the mass market. The opening line mentioned a specialized global mission, and here it comes into focus. Prioritization extends to international partners with unique, urgent needs. Groups operating in extremes, scientific expeditions, conservation teams, disaster relief agencies. They need small, customized runs delivered on schedule. An aid order after an earthquake may move to the front of the line. The logic? Vehicles that can save lives now rank higher than daily commuters. not a judgment, but a practical choice. Purpose over profit. We see production totals, not internal allocation. Many trucks are spoken for. Global deployments become proof of concept, reinforcing consumer value. There's pride in knowing the same standard serves volcanoes and medical missions. That global demonstration comes first. That thought stays with you. Specialized mission-ready builds create a ripple effect across manufacturing. Both types share the core line, so changes for one can delay the other. Different harness, pause to swap parts, reprogram robots, retrain workers. Constant switching is inefficient versus mass-producing one identical product. Like a kitchen, faster to plate one dish 100 times than 10 different orders. Each specialized variant acts like a custom order that slows the overall pace. The complexity spreads to suppliers handling standard parts and unique tactical components. Small batches may require retooling, causing delays that cascade back. The supply chain is a delicate web. Tug one strand, others move. Production is more like locks and dams. Flow controlled, sometimes stopped to manage priorities. Ensuring exacting standards is a hidden tax on speed, paid to guarantee capability for the most demanding users. We often talk about factories like machines, but they are run by people. The human element is critical, and a brake on how fast production can ramp. Novel materials and methods require extensive specialized training. You cannot master stainless welding or high-security electronics overnight. Sections of the line pause for hours or days to teach and practice. Training is a necessary investment in quality and safety, but it reduces volume now. Many machines are custom-built for this truck. Installation and calibration are painstaking. Robots must be programmed with extreme precision. Errors waste parts. Setup and calibration take months, with ongoing adjustments after start. Picture careful, deliberate work, pioneering a new way of manufacturing. Designers, engineers, and operators solving problems never solved before. It ensures each truck is built right, slowly, for now. So, we return to where we began. The long line is real, and the company is indeed struggling to build them fast enough. But this is not failure. It is deliberate choice. Scarcity stems from building a vehicle that serves a dual purpose. To be a revolutionary truck for the public. To be a dependable tool for high-stakes, global missions. That choice demanded extraordinarily tough materials and slower invented processes. It necessitated highly secure and reliable software and hardware, where meticulous validation outranks speed, balancing general consumers with urgent tactical and humanitarian partners, often with priority. In the end, the Cybertruck is not simply sold out, it is spoken for. And perhaps, that tool is worth the wait.